Hey guys, it's Mrs. Denton and you are watching a video about notes for identifying angles. This is part of the G2 unit. In this video, we're going to learn about 5 different types of angles that we haven't studied yet, and we're going to review 2 types of angles you've already learned about. Let's get started. A couple of vocab words here to clarify things before we get going. We have this picture. We've got 2 lines going horizontally and 1 line slicing through them. This line that's slicing through, like this, I'm highlighting it pink, this line here is called a transversal. Transversal. Okay. A transversal is a line that passes through 2 or more other lines. A line that passes through two or more, so I'm going to say 2 plus, 2 or more other lines. So we could have all kinds of lines going horizontally, and this line that's cutting through would still be the transversal. Okay, well, once you have this set up, 2 lines with the transversal, it creates a total of 8 angles. Check that out. 1, 2, 3, 4, 5, 6, 7, 8. 4 of these angles are considered interior, and that's these 4. I'm going to put a capital I for interior on these 4 angles. These angles are between the 2 horizontal lines. They are inside the 2 horizontal lines. So I'm going to say interior angles are any of the 4 angles between the 2 lines. Interior angles. The angles inside the 2 horizontal lines. Okay, well, the opposite of interior is exterior. Exterior, I'm going to put a capital E in all of the exterior angles. Exterior angles are the 4 angles on the outside of the 2 horizontal lines. Any of the 4 angles outside of the 2 lines. Okay, so we've got 2 random lines. We've got a transversal cutting between them, and that creates 8 total angles. 4 interior angles and 4 exterior angles. Understanding interior and exterior is really going to make this next part go so much smoother. All right, the first special angle we are going to learn about. Okay, we've got all these special pairs of angles coming. The first special pair of angles that we're going to learn about is called an alternate interior set of angles. Now we've got interior here in the title. Okay, so for interior, you're checking out one of these 4 angles. Angle 3, 4, 5, or 6, because this is the interior space. Okay. The word alternate, or to alternate, means to go back and forth. So we've got our transversal line going straight down the middle. And out of these interior angles inside here, to alternate means to go across the line. So I could use angle 3, and on the alternate side of the transversal is angle 6. Alternate interiors. I also could identify angle 4 as an interior, and its alternate pair would be angle 5. Alternate interior angles. So an alternate A set of alternate interior angles are on opposite sides of the transversal. Opposite sides of the transversal, but it's not a linear pair. It is not a linear pair. Be real careful there. Okay, alternate means on opposite sides of this pink transversal, but it's not the linear pair. So 3 and 4 are the linear pair, but 3 and 6 are the alternate interior angles. So angle 3 and angle 6 are set, and so are angle 4 and angle 5. Okay, alternate interiors. The next pair we're going to look at has two names. Sometimes they're called consecutive interior angles, and sometimes they're called same side interior angles. Notice we're still talking about the interiors. So we're still talking about this space between the two horizontal lines. Okay, so same side interior kind of gives it away. If I'm looking at angle 3 again, what other angle is on the same side of the transversal, but also is in the interior space? Well, that would be angle 5. Angle 3 and angle 5, they're both interior angles and they are on the same side of the transversal. Angle 3 and angle 5. Okay, how about the other side of the transversal? We've got angle 4 as an interior, and on the same side, on the right of the transversal, is also angle 6. So angle 4 and angle 6 are considered same side interior angles. So a quick description would be they're on the same side of the transversal. Forever and ever and ever, these angles were only called consecutive interior angles, and just recently, the SOL has been naming them same side interior angles. Okay, the next set we're looking at, let me move my camera down here. The next set we're looking at are called alternate exterior angles. Okay, exterior this time. I'm underlining exterior. So we've got our transversal again. We've got our two lines. Exterior is the space outside of the two lines. Okay, so we are talking about angles 1, 2, 7, and 8 as exterior angles. Now, if we go back to understand what the word alternate means again, or to alternate, it means to go across, to jump back and forth, to alternate. So if I start with angle 1 as an exterior angle, to alternate would be to go across the line. Now I'm pointing at angle 2, but that is not an alternate exterior. Angle 1 and angle 2 already have a relationship. They are called a linear pair. So I have to jump down here to angle 8, alternating across the transversal and outside of the two lines, alternate exterior, angle 1 and angle 8. We've got another set of alternate exterior angles. Take a look at angle 2. Angle 2 is on the right side of the transversal. Angle 7 is on the left side of the transversal. There's your alternating, opposite sides. Exterior means outside the two parallel lines. So angle 2 and angle 7. So a brief description, alternate exterior angles. Opposite sides of the transversal But make another note here, not the linear pair. A lot of students want to call alternating pairs the linear pair, but it is not the linear pair. You have to use the second intersection. Okay, let's check out our next side here. Flip over. Okay. Our next angle pair is called same side exterior angles. Okay, well, we already had same side interior angles, so let's see if we can use some of the same information. First of all, exterior is this space out here outside of the two horizontal lines. So again, we're looking at angles 1, 2, 7, and 8. Those are exterior angles. Same side exterior is telling me that when we pick a pair, they have to be on the same side of the transversal. So here's my transversal again, bright pink. If I want to pick angle 1's same side exterior, angle 1 is on the left, so is angle 7. They are on the exterior of the two lines, and they are on the same side of the transversal. Angle 1 and angle 7. How about the right side? We've got angle 2, which is an exterior angle. And if you go to the other exterior on the same side of the transversal, we've got angle 8. So same side would be angle 2 and angle 8. So a little description about same side exterior angles. They're on the same side of the transversal. Same side of transversal. And also outside of the two lines. Okay, same side of the transversal, outside the two lines. We have one more new pair to talk about. And if you take a look at this next title, corresponding angles, there is no mention of the angles being interior or exterior. Corresponding angles are a little different than all the rest. To correspond means to be in the same position. To be in the same position, but at a different vertex. At a different vertex. Okay, so let's check this out. I've got angle 1. I would describe angle 1 as being on the top left of this intersection. If I cover up the bottom intersection, I'm just looking at angles 1, 2, 3, 4, then angle 1 is on the top left. So if I'm trying to find its corresponding angle at this second intersection, I'd be looking for the angle sitting in the top left position, which would be angle 5. So angle 1 and angle 5 are an example of corresponding angles. Same position, but at a different vertex. Okay, let's try again. Check out angle 3. Circle angle 3 here. Cover up the bottom intersection. Angle 3 would be on the bottom left of this intersection. On the bottom left. So what is in the bottom left position of the lower intersection? The bottom left is angle 7. So angle 3 and angle 7 are a set of corresponding angles. Okay, let's keep going. We can go all the way around here. Check out angle 2. I would consider angle 2 in the top right position of this intersection. So in the lower intersection, it would match up with angle 6, which is in the top right of its intersection. So angle 2 and angle 6 are a corresponding pair. And then we have one more here. We have one more corresponding set. We've got angle 4, which I would consider in the bottom right of its intersection, as a match to angle 8, which is in the bottom right of its intersection. So angle 4 and angle 8 are a corresponding set. Okie doke, so those are the 5 new angle sets, and I know that's a lot going on, so we're going to definitely have to practice that vocabulary. While we're at it, I don't want us to forget about the 2 sets that we have already learned about. So let's refresh quickly what vertical angles and linear pair angles are. Vertical angles are non-adjacent angles formed by intersecting lines. The non-adjacent angles formed by intersecting lines. Now, very important. When we were studying vertical angles, we did not need 8 angles to find a set of vertical angles. In fact, we only needed 4. So I can cover up this lower half completely, and I still have 2 sets of vertical angles here. We've got angle 1 and angle 4. Those are the non-adjacent angles formed by these 2 intersecting lines, angle 1 and angle 4. And we've also got another set, angle 2 and angle 3. That is another set of vertical angles. Now notice again, we did not need this lower set of angles in order to describe these. If we look at that lower set of angles, we'll notice that there are 2 more sets of vertical angles here. We've got angle 7 and angle 6, vertical. You could cover up this top intersection and notice that angle 6 and 7 are across from each other. So angle 6 and angle 7 are also a set of vertical angles, angle 6 and 7. And then that would leave the last set of angle 5 and angle 8. So angle 5 and angle 8. It's really, really, really important to remember that you do not need 2 different intersections to find vertical angles. Only one intersection is needed. So let's make a note of that. Doesn't need 2 intersections. You could split this picture in half and still be able to find vertical angles. Okay. Our other angle that we've already learned about that we should refresh are a linear pair. Now we've had a little trouble with linear pair, but we're going to get it all worked out. If vertical angles are the non-adjacent angles formed by intersecting lines, then we could say that the linear pair is the adjacent angles formed by intersecting lines. Okay. Vertical angles are the non-adjacent pair, and a linear pair is the adjacent pair. That's the difference there. So let's take a look at our picture over here. Okay, we've got, again, we were learning linear pair before we threw in a whole bunch of intersections. So just look at the top intersection with me. On the top, we could say angle 1 and 2 are a linear pair. They are adjacent to each other. They form this line. So angle 1 and 2 could be a linear pair. Now, we could have also said, this is going to get a little crazy, we could have also said that angle 1 and angle 3 are a linear pair because they are also adjacent to each other and they form this line. So we could have also said angle 1 and angle 3. We could do this all the way around the intersection. We could say angle 3, while it's linear with angle 1, it's also linear with angle 4. They are side by side adjacent and they form a straight line. So angle 3 and angle 4 are a linear pair. And lastly here, we could say that angle 4 and angle 2 are a linear pair. They are adjacent and they form this line. Angle 4 and angle 2. Now we haven't even gotten to the second intersection and we already have 4 sets of linear pairs. So if we throw in the second intersection, there's going to be 4 more sets of linear pairs. Okay, so let's try it here. What would be a linear pair with angle 5? Cover up the top intersection if you need to. Angle 5 is adjacent to angle 6 and it's adjacent to angle 7. So angle 5 and angle 6 are a linear pair, and so are angle 5 and angle 7. We can keep going around. Angle 7 is a linear pair with angle 5, but it's also a linear pair with angle 8. Angle 5 and angle 8. And lastly, while angle 8 is a linear pair with, I said angle 5, I meant angle 7, angle 7 and angle 8. And lastly, while 8 and 7 are a linear pair, so is angle 8 and angle 6. They are adjacent to each other and they form a line, supplementary angles. So with a linear pair, there are actually 8 combinations that form a linear pair. Okay, what I want you to do in this bottom part is I'm going to pause the video, or I recommend you pause the video and see if you can identify each of these pairs correctly. This first pair is a pair of alternate exterior angles. They are on opposite sides of the transversal and outside the horizontal lines. Try the next one. This pair are same side exterior angles. They're on the same side of the transversal. They're both on the left, and they are exterior angles. Try the next one. This is an alternate interior set of angles. They're on opposite sides of the transversal and on the inside of the horizontal lines. And now you have one more to try. This last set is a set of corresponding angles. They are both on the top right of their intersections. Corresponding means same position, different vertex. Okay, that's all for the notes on this new topic. That is a lot of vocab, so we're going to be doing a lot of vocab checks. Keep this sheet handy.